Good evening, sir. Yes, sir.
Okay, so today we are going to start a new section. So that is our last section of this course. That is the GSM security. So this is actually the related to the mobile networks. Uh, so let's start our discussion. Now, this is what I am planning to discuss today. So as usual, so before going to discuss about the wireless telephone communication, I thought of discussing the wired networks a little bit because at the end of the day, all these wireless networks are going to be connected to the wired networks. So for the infrastructure, we have discussed that before in the Wi-Fi networks as well, because though we have Wi-Fi networks at the last mile, but anyhow, we have to connect to the wired network to be connected to the ISPs and to the infrastructure. So therefore, I plan to discuss about the wired networks and how it works. Then we'll discuss about this GSM networks and from 1G to 5G, sorry, the 4G security threats and the security mechanisms that they have used. So I think we have done a separate section about the 5G in the special topics section by a foreign lecturer, not a Sri Lankan one, but staying in a foreign country. So anyway, we'll discuss 5G again later and the security related to 5G. So this is the plan. Uh, right. Okay, now when we starting or when we discussing about this telephone networks, we called it as public switch telephone network or PSTN. So uh, at the initial stage, you can think that we have our telephones and each and every telephone is connected to each and every other telephone. So that is this kind of situation. This figure one shows this fully interconnected networks. So that is where to do the communication, it says that all the devices has to be connected to each and every other devices. So which is not practical, but it is one of the network topology that we have a fully interconnected or a mesh like of connection. So this is the very basic kind of network that we can have in this in the telephone networks. But it is not practical, so you can see it because when the number of devices get increased, so you can't do it. It is not scalable. So the next architecture is the centralized switched architecture. So in that case, all these telephones, so these nodes are telephones, right? So these dots are telephones. So all these telephones are connected to a central switch, right? So at the beginning, in the initial stages, so there's a person at this centralized switch. So that's a huge switchboard kind of thing. And when you want to make a telephone call, you are connecting to that centralized switch or an operator. So at that moment, they were called as operators. So you make the call to the operator, and then the operator actually manually connect your connection to that to the destination or to the person that you want to call. So if this guy wants to make a call to, let's say, this guy, then they have to contact the operator, and operator is going to manually connect you to the destination. So this is like a circuit actually, right? So we'll discuss about the circuit switching and packet switching later. So they're actually creating a circuit from here to here. So you are connected through a wire to the destination. Then you can make the call or you can do the voice communication. So that is the initial stages. So all these things have some initial stage. So that get developed based on the requirements. So after some time, when the number of devices get increased, what happened was then another level of this switch came. So that's where you have this two-level hierarchy. So in this case, this is one centralized switched architecture, and that is connected to another level or higher level of switches. So likewise, you can connect each of these centralized architectures together to a two-level architecture, right? So with this, you are actually increasing the number of devices, and if you want to make a call, then you connect to this operator, and that person will forward it to this, and finally to the destination that you want to call. So in this case, uh, the network expands, so the scalability is there. So not like in the fully interconnected network. So it is scalable and it is practical. So at the initial stages, you can understand that there were people. So people manually interconnect all these things and they do the communication. So at that time, they were called as operators. So I think that's the name actually came for the for this uh, new network service providers as well. So sometimes we call them as operators. So this is the basic or the history about these public switch telephone networks. If I can remember correctly, I think I took this diagram from Tannenbaum's network book, right? So if you are interested, you can go through Tannenbaum's computer network books. So it has some historical information and some other details about these uh, basic topologies. Now, okay, so this is somewhat uh, 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 abstract diagram about the PSTN. So initially we discussed that all these centralized switches and all these things are people, so they manually do the thing. But later on, it is not practical to do all these things manually. So somehow those things become electronics, right? Electronically operate all those things. And later on, we have some abstract topology or architecture of the PSTN. So you can see that at the ends you have these telephones, right? So at the ends you have telephones, then you have different levels of office. So end office, tall office, intermediate switching office. So likewise you have different office, all these different switching stations where you pass through the connection and finally you connect both these ends, right? So now these things get developed and they become electronically operated, right? And you can see that these links have become trunk links, so which means there are more information traveling through these things, not like a single connection or a local loop. Now they become trunk links, right? So parallelly they will do the communication of number of telephone calls or telephone connections. So the thing get developed and it become more uh, advanced, right? So anyway, in this case, we actually do the communication in uh, some electronic signals, right? And these are not kind of digitals, which means ones and zeros, not ones and zeros. We are sending analog signals in this case, right? So then later on, people need to do the data communication as well, right? So that is with the introduction of the internet and this web services, they wanted to do the data communication as well. So in that case, uh, without using a separate or different infrastructure, they plan to use the same PSTN network or PSTN infrastructure to do the data communication as well. So originally, PSTN was implemented to do the voice communication. It is simply the telephone network. So as the name says, public switch telephone network. So it is designed to do the telephone communication or voice communication, right? But later on, people need to do the data communication, but rather than having a different infrastructure for that, so they decided to use the same telephone network to do the data communication as well. Because already we have this telephone wires and everything in the cities and the different locations. So we have all these wires and cables and everything is already there. So rather than having another set of wires to do the data communication, the people thought of doing it using the same infrastructure. So with that, they can reduce the cost because otherwise you have to lay a different cables to do the data communication. So what they did was they used the same PSTN network and somehow convert that digital data into uh, this voice communication medium because the telephone or PSTN is optimized to do the voice communication, basically the telephone communication. But what they did was they somehow convert the data into that format and they use the PSTN network to do the same communication. So that's where we have these modems, right? So you have uh, the network or the infrastructure that is PSTN infrastructure is there. So rather than having a new infrastructure, what you do is you simply convert these ones and zeros to voice signals and use it or these analog signals and use the same PSTN network to do the communication. So that's where we need this modem, right? So if you have used these modems, right, that telephone modems, then sometimes you might have actually listened to the data communication, right? So when you start the communication, you actually hear the data, the sound of the data, right? So that is how they use the same infrastructure to do the data communication. So at one end you have ones and zeros, then that will be converted into this analog signal or whatever this voice signal and use it or use that signal to send through PSTA. And on the other end, again, you should have a modem and convert that analog signal to the digital signals or ones and zeros. So with that, the people have reduced a lot of cost, right? And do the do both the things, the voice communication as well as data communication using the same network. But still, there were a lot of problems because the data rate is very low. So at that time, they had around 56K speed, right? So that is very low. But at the moment, that is sufficient because they don't have a large content, right? So that's only sometimes it's text-based things. So that speed is more than enough to do their work. But they had some problems because you can't do both voice and data communication parallelly. So at one instance, either you can make a call or you can do the data communication. So that's one limitation that they have. And the other one is this the speed, right? So people thought of this and they wanted to improve this. So after that, they introduced this DSL communication, the ADSL, SDSL, likewise the DSL communication. So when they design the DSL communication, still they have the requirement to use the same infrastructure. So they don't want to change the wires or whatever the other devices in the middle, or whatever this telephone post, right? So they don't want to remove anything, or they don't want to remove the cables or replace the cable. So they want to use the same infrastructure again and improve the speed, and they want to do the data communication and voice communication at the same time, right? So that's where the people have introduced the DSL, right? So yes, I have some information about the DSL as well, the digital subscriber line. So normally we call it as XDSL. So either you can put A or S, symmetric or asymmetric. So that's because you are actually dividing this full bandwidth into different small channels. I think I have image. Yes. So this is the entire bandwidth that you have in the PSTN cable, right? So because still we are using the same Cat3 cables to do the communication, right? So you have the bandwidth, and that bandwidth is actually divided into smaller channels, right? So you have small channels, and one channel is dedicated for the voice, right? And after that, you kept some space, so that is to reduce the interferences and all the things. So you keep some space, and after that, you give the rest of the channels to do the data communication, right? So this is actually 4 kilohertz, 256 channels. So you have 256 different channels with 4 kilohertz channels, right? So either you can separate these channels to uplink and downlink symmetrically. So if you divide the channel symmetrically, then that will be SDSL. And if you divide the streams in an asymmetric way, then that will be ADSL, or asymmetric digital subscriber lines, right? So this is the solution that they have given. So without changing the infrastructure, without changing the PST and network, they have improved the speed, and as well as they can do both the data and voice communication parallelly, right? So yes, I have put some images of this DSL architecture, so you can see you have the voice switch and as well as the data. So both these things were combined and used the same telephone line to do the communication. And at the user's place, again you have a splitter, and then the voice channel is separated and sent to the telephone, and the data part is sent to the modem. So this is how the digital subscriber line works. So I just wanted to give you some idea about the PSTN network, because when we are using the mobile uh, networks or GSM networks, again finally you have to connect to the PSN network, right? Or this telephone networks, right? So because of that, you need to have some idea about how this PSTN network works, right? So that's why I put these two, three slides at the beginning of the lecture. So as I told you, we have this different uh, components in the PSTN network. So we have this is telephone, means actually it is the uh, uh, customer's device, right? So that can be telephones or that can be fax machines, right? Modems or whatever the device. So which convert this and whatever the voice into electrical signals, right? And you have this local loop. So that is basically the last mile between you and the final switch or whatever it is, right? So that means you have a physical wire or a copper cable from your device or your telephone to the local exchange, right? So that is the end office, right? So there is uh, end office or uh, local this local exchange, right? So there has to be these switching centers here and there, right? For a small town or for a village. So there has to be this local exchange or this end office, right? So basically they have to route these calls to the next level, or if they are within the same level, then they have to do the routing part or this call routing. So then we have the trunk links, right? So these things are higher capacity transmission lines, right? So because you need to uh, do or you need to carry multiple telephone calls simultaneously, right? So they might use some multiplexing techniques, right? But anyhow, this trunk line should be able to carry multiple calls simultaneously, right? Then you will have this role office or intermediate office, right? Or sometimes junction network. So they're known as different names, right? So these troll centers. So these things are having some higher level routing or switching kind of things and uh, uh, intercity communication kind of things. So they have to handle these kind of things. So then sometimes you might have this international gateways, so where you need to handle the international telephone calls. So likewise, you need to have very sophisticated or very advanced network and devices to handle this kind of communication, right? So that's why the people wanted to keep this same infrastructure because they have invest on that very much, right? So they have done a huge investment for this PSTN network. So they need to do the data communication through this same infrastructure. So rather than spending money for again for another infrastructure. So I hope that requirement and how these things work clear for you. And so that's why we are using a modem and using the same telephone link to do the communication. So I know that now it has changed, right? Because now most of the time we have this fiber network, so which means that infrastructure has changed. So they have removed the copper cables and now they are using fiber optics. So that is because they need to give more speed to the network. So therefore, somehow they have decided to remove the copper cables, and the technology has changed. So now it has become fully digital. So yes, the things change. But anyway, that's the main. These are the main reasons why the people keep in the same PSTN network and try to improve the data communication on top of that. Right. Okay. Now this is another important thing: the packet switching and circuit switching. So though this is, you will see that it is a wired kind of thing. So it is actually related to the wireless networks as well. So we have two types of switching, that is packet switching and circuit switching. So as I mentioned you before, in this case, so this is basically a circuit switching, So when you are making a telephone call, so actually you are connected from your end to the receiver, right? So it is basically you are totally uh, 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 a link or in a connection. So if you check this diagram, so you can see that this is one end and there's another end. And if you check all these switches, so this is connected to this, and it is connected to this, and it is connected to this, and through this to the final telephone. So this is a circuit, right? So it is like a single wire. So you have a single wire from this one end to the other end, right? So you have a circuit in this case, right? So you have a single wire connected from one end to the other end. Yes, these are connectors. So this one will be connected at this moment to this, and maybe in the other case, it will be connected to this, right? So anyway, you have a single path from one end to the other end. So there are advantages and disadvantages of this formation in the circuit switching formation. So you have a dedicated line to do the communication. So you have the entire bandwidth, right? So, and you are the only two people in this communication. So you can do the communication without any issues. But the problem is if something fails, if this switch fails, then there's no more connection, right? Because it is similar to a breaking of this wire. So if the wire broken, then there is no connection between two ends. So that is one problem with this circuit switching, right? So you have all these things. So it takes some time to initiate the connection. So that is the only latency that you have, or a delay. So it takes some time to initiate the connection. But after that, the connection is there, right? But if something happens at the middle, then you don't have any connection between the two ends, right? So we have another formation or another method, that is the packet switching, right? So in this case, you don't have a dedicated circuit to do the communication. So you are dividing the message into small packets and send them through the network. So they will find a path, and somehow the messages will be delivered at the other end, right? So the message is divided into small parts or small packets. Then they simply send it to the network, and somehow they find the path and send it or deliver it to the receiver. So with that, the receiver can get the messages, right? So that is packet switching. So circuit switching and packet switching. In packet switching, you don't have a dedicated path. So one uh, packet might use this path and send to the receiver, and the second packet might use this path and send to the receiver, and maybe another packet might use this path and send to the receiver. So likewise, it might use different paths and somehow deliver to the receiver, right? So you don't have a dedicated circuit or dedicated path in this case, but the messages will somehow delivered to the receiver, right? So two methods, there are pros and cons, right? But anyway, these two methods are used to do the communication. So the important thing that you have to remember is in PSTN or in this telephone communications, so we are having a circuit switching setup, right? So you initiate the connection with the receiver and then do the communication. So if something happens at the middle, then you lost the connection, and after that again you have to initiate the connection through a different path and do the communication. So in packet switching, you don't have such kind of things. You divide the message and send it to the network, and somehow the messages will be delivered at the receiver, right? So that is packet switching and circuit switching. Okay, so that is the basic idea that I wanted to give you about the PSTN networks, right? The telephone networks and the packet switching and circuit switching. Right, so if you have anything to note down, please write them down. Right, now let's come to the topic, that is the cellular networks. So again, I took this diagram from the Tannenbaum's network book, computer network book, if I can remember correctly. Now, so you might remember that initially before 15 to 20 years back, right? I think more than 20 years, people use these cell phones, right? So actually that's the name that they have used, cell phones, right? So they were very huge brick-like phones, right? And at that time it is very costly to do this cell phone call, right? Even you had to pay for the incoming calls as well, right? So there were a few uh, service providers like Celltel. I can remember one service provider, Celltel, was there. And anyway, the device is very huge, and we call them as cell phones, right? You might have remembered, right? Cell phones. So, can anyone guess the reason why they were called as cell phones? No idea? So actually, that is not because of the size of the phone or the formation of the phone. It is basically because of the network, right? So we called it as a cellular network, not because that the mobile phone is small or uh, 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 I mean independent device without any wires. So that is the name cell phones came because of the cellular networks. So the reason is this is actually geographical location. So this diagram shows some geographical locations. So we call all these small locations as cells, right? This hexagon shape uh, cells are the locations, actually, the geographical locations. So you have cell towers in each and every cell, right? Or we call them as base stations. So each of these cells, they have these cell towers, right? Uh, and the cell towers, they have the thing called BTS, base transceiver station, right? So in different networks, they will called as in different names, right? So when it comes to 3G, they'll node called as nodes. So anyway, we have some transmitters and receivers in these cell towers. So the reason for using this cell architecture or this cell formation is to reuse the frequencies, right? Because we have some limited number of frequencies So if we have a formation like this, then we can use a single frequency within one cell and a different frequency in the next cell. So likewise, we can use a set of frequencies, and after that, again, we can use the same frequencies in a different or in a very far away cell. So that will reduce the interferences. So if we use the same cell frequency within a close by cells, then they might get interfered, right? So therefore, with the cell formation, what they do is they use the same frequency in two cells with a very far distance, right? So because of that, they can reuse these frequencies, right, without interfering to the others. So this is the formation of the cells. So that's why we called it as the cellular networks or cell phones, right? So in cellular networks, basically we have the mobile devices. So in some places or in technical documents, sometimes you might see them as user equipment, right? Because it might not be a mobile phone, right? It can be some other devices, right? Which are capable of reading the signals. So therefore, sometimes they might have referred them in user equipment, right? So whatever the device which can listen to the signals from the nearby cell towers. So those are the user equipments, right? And you have this radio communication within the cell, right? So that's how you are going to make these calls or do the data communication. So your mobile device will send and receive radio signals from the closest cell tower, because uh, always your device will search for the cell towers, right? So it will connect with the cell tower which has the highest strength, the signal strength. So which means the closest cell tower, right? And within this cell, we have, as I told you, we have the base stations. So you can remember that in wireless networks also we call them as base stations, right? So you will find base stations in this cell, within the cell, inside the cell, which do the radio signal communication, right? And there are some other components. So we will discuss these different components later, right? So they have this BC, BSC, MSC, likewise different components. So we'll discuss them later. So this is the reason why we call these things as cellular networks, right? So not because of the shape of the mobile phone, it is because of the network. And so the network is cellular, and it is actually this hexagonal shape. So even in all these documents and everywhere, it is drawn in hexagonal shapes, these cells, right? So that's why we call them as cellular networks. Yes, so from 1G to 5G, this G means something. So there's a significant improvement from one level to the other level. So that's why we label them as different generations, right? So I have mentioned some of these differences between these different generations. That is, the one thing is the one observable or one thing that we experience is the data rate. So fast data rate. So you won't see the capacity, you won't feel that capacity, but you feel the data rate, right? So when you do the communication from generation to generation, you will feel the speed of data, right? And similar, the voice communication also improved, but again, it is not that much. I mean, uh, uh, it is difficult to experience that when compared with the data rate, right? So data rate, you will experience it. So From 3G to 4G, you feel that. From 4G to 5G, you will feel that there's a huge uh, gap in the data rate. So huge improvement in the data rate. But still, this voice also improved, but it is not that it is difficult for you to experience it. So it getting the latency of the network get lowered, right? And from one generation to the other, so they add some features, right? So as an example, from in 1G, you have only the voice communication. So it's only voice, right? But when it comes to the 2G, then you got the SMS features, right? Then everything become digital. So likewise, some new improvements are there, right? And later on, some internet or data communication introduced, right? So gradually, everything improved, and so somehow it came to this uh, uh, voice over IP features, right? So likewise, in each generation, you get some new features as well. Right? So that's why we label these things as different generations. So there's a significant difference between one generation to the other generation, right? So that is the reason we label these things as different generations, right? So let's get a brief information or little information about each and every generation. So normally uh, we don't see this 1G because we name this as 1G because we got 2G, right? So that's the reason why we name this as 1G. So this is the first generation of cellular communication. So it is totally analog, right? So it is not digital, it's analog, right? And the people use this only for voice communication. So you can take calls. That's all, right? So the speed and this rate, so it is not visible because you won't feel it, but this 2.4 kbps, that is the speed that they have, data transmission speed. So call quality poor, right? So uh, it is not stable, so you have some issues with the communication, right? So there are some problems with this generation. So that's why the call quality says poor, right? So it is the calls get dropped. So likewise, there are some problems. And the other thing is these devices are very huge, brick phones, right? And you need to use a lot of energy to do the communication. So, and the cost is not included in this list. So it is not cheap, right? So having a mobile phone at that uh, age or in this first generation is not a easy task, right? So it is very costly, right? So security. So there's no discussion about the security. And so this is the first generation. So calls can be intercepted, right? So no encryption because this is basically analog communication, right? And remember, it is circuit switch. So that's why I discussed circuit switch before. So it is not only for the wires, right? Wired communication. So this is wireless communication, but still it has a circuit because before do the communication, you have to initiate that link between the end devices. So that's why you called it as circuit switching. So it is not packet switching. You are not uh, divide the information into packets and send them in the networks. It is circuit switch. So you need to have a proper circuit between send and the receiver or the two ends and then do the communication, right? So it is the first generation. It is where all it has begun, right? So there were a lot of problems. So no discussion about the security. So calls can be intercepted. So no encryption. So likewise, this is very basic, right? But anyway, this is the starting point of the mobile communication, or this the cellular communication. So later on in 1990s, so the 2G introduced, right? So actually 1980s, the first generation was introduced at around 1980. So if I can remember correctly, Japan was the place where introduced this 1G, right? So just read about it. So if you are interested, right? I'm not going to ask in the exam paper where when the generation one was introduced, right? So I'm not going to ask such kind of questions. So if you are interested, you can check it. So if I can remember, it was introduced in Japan, right? Somewhere in 1980s, the beginning of 1980s, they have introduced 1G. So in 1990s, this 2G, 2G was introduced, right? So I put some information, right? So I try to put the same categories, right? So technology, it is GSM, Global System for Mobile Communication, right? And CDMA. So we discussed CDMAs before, right? So these are broadcasting networks. So they have to have some mechanism to do the communication, right? And the voice calls improved because now it is not analog, it is digital, right? So they have changed it to digital. So the quality has improved and SMS was introduced, right? So that is one uh, uh, feature that they have introduced in the 2G. And the third one is the data connection, right? So at that time, they had some protocols like WAP, wireless application protocols. So 2G, you can do some data communication, right? So you were able to use those 2G connections to connect to the web services and get some communication or do some communication with the internet, right? So that service was given by 2G. So the speeds are very low. So I have put some information about the speeds, right? So you have this GPRS edge. So there were different technologies at that time, right? So little improvements, right? Uh, and the other thing is now the devices get improved, so they become relatively smaller when compared to the brick phones, and they become affordable, and the battery life improved. So likewise, some improvements are there, and I have mentioned some security protocols as well. And so now it is digital, so you can do some encryption, right? So you can do some encryption in the data communication, and the SIM card is also there. So we'll discuss about these SIMs later. And so have some information saved in this SIM card. It is a smart card. So you all have SIM cards in the devices. So later on now we have eSIMs. But anyway, this that's a physical SIM card, so which has some information saved there, right? So that will be used to do the communication. So that is some improvements, and there are some problems in these different encryption protocols. So we'll discuss them later in detail, right? And network. So now uh, for making calls, you have circuit switch network. So that is when you want to make a call, it has to create the circuit and then do the communication. But when it comes to data, GPRS and edge, then you have the packet switching. And so you have both, right? So Yeah. So that's about the uh, 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 2G networks. All right, so I have some other information. Okay, so this is the GSM or the 2G architecture. So in the 2G architecture, we have different components. This mobile stations, base station subsystems, network switching subsystems, operating support subsystems. So all these things are components, right? So there are some other components as well. So though I have mentioned those things, so let's discuss some of these things. Mobile stations means basically whatever the user equipment, mobile phone or whatever the other devices that you use to do the communication, right? So when you called as the mobile station, it is a combination of the mobile equipment as well as the SIM, right? So you might have a mobile equipment. So these days also we have mobile equipments like let's say the tabs or iPads where you don't have you don't have to put the SIM card. So so that is not going to connect to the cellular network. So therefore it is not considered as a MS in this stage. It is not a mobile station because it cannot connect to the network because it doesn't have the SIM card. So in this case, mobile station means you have the mobile equipment plus the SIM, right? So subscriber identity module, so that is SIM. So you should have both. So when you have both of them, that is a mobile station, right? So it is connected to the cell tower, right? And the cell tower is going to connected with this uh, some other components. So I have a diagram, so I will show you the diagram. And then we have this base station subsystem. So this uh, the base station subsystem is the component which going to handle the network traffic, right? And it handle the signaling between these mobile stations and the network switching subsystems, right? So that is another component, the BSS. Then, yes, I have the diagram. So we have the other component that is BSC. So BSC means base station controller. So base station control, these are base stations, uh, the cell towers. So BSC is the base station controller which controls several BTS, so these base stations, right? So this is the component which control these uh, base stations. And then we have this MSC, that is the mobile switching centers. So that is connected to multiple BSCs, right? The base station controllers. So this base station controllers going to be connected to the mobile switching controller. So switching center, the MSC, right? And in the MSC, you have another two components, that is the HLR and VLR. So HLR means the home location registry, and VLR is the visitor location registry. So these are basically kind of databases which keep the information about the subscribers, so which means about the users, right? So they keep some information there. So when you buy a new package, not a package, the connection from ISP, then they load all this information in HLRs, right? So it has all the information related to you, the SIM card, when you purchase a SIM card. So HLRs, this kind of a database. So you do all these authentication kind of things based on that. So you have different components to the authentications, right? So we'll discuss them later. And we have this VLRs, that is again a database, right? Visitor location registry. So it is uh, dealing with the location of this mobile subscriber. So where it is actually located. So which service area is the particular device is located. So it keeps some information about the subscriber, right? And you can see that from MSC, it is going to connect to the PSTN. So that is the public switch telephone network. So you are going to connect to the telephone network after that. So all the information will be comes from the MSC to BSC and this BTS or the base stations, and that will be converted into whatever the radio signals and sent to your mobile devices. Right? So you can see that in Tannenbaum's book also they draw it as the mobile phone and the SIM. So both should be there. So that in that case you can call it as a mobile station. So SIM card should be there, right? So otherwise it will be just a device which is not going to be connected to the network, right? Okay, so I have some expanded diagram as well. So this is because when we, in this case, you have the voice communication, but normally we have the GPRS or the data communication as well. And so in this diagram, you can see all the abbreviations and their long forms. So MS means the mobile station, right? And these are BTS. So these base stations, right? Base station uh, where are these cell towers, right? And they are connected to these BSCs, base station controllers, right? And you can see that it is connected to the MSC and sent to the PSTN. So you have the HLRs and VLRs, and these things are related to the security, this uh, AUC. So that is authentication center. So we'll discuss about the security later. So you have the AUS and these uh, EIRs. So again, two different components, right? So the change in this or the difference in this case is this GPRS component, right? So that is where the data services, right, are provided for the 2G network, right? So you have a separate core for that. So this handles the voice communication and this handles the data communication. So when you enable GPRS on your mobile phone, so if you can remember initially at that stage, it is not, so you have to get the relevant information from the ISP. So they will push the information to your mobile phone and then you have to, it takes some time to set up the GPRS. So the settings will be sent to your mobile phone, right? And then it can do the communication. So it is not uh, like the easy as these days. So the GPRS settings has to be sent from the uh, mobile service provider and it has to be set up and then you can use the GPRS service, right? So we have some components, this SGSN, so it should be in this list, service GPRS support node, right? So this manage the packet data for the mobile station, right? So that is handling these data packets. And you have the gateway as well. So this is GGSN, gateway, GPRS support node. So it is like the gateway where you are connecting to the internet, right? So again, two components. So whatever the messages or the data that you are sending will comes from your device to the BTS, then it will be forward to the BSCs, then to SGSN, then the SGSN will be forwarded to GGSN, and then it will go to the internet, right? So again, when a packet comes from internet to your device, so it comes to internet, to the GGSN, to SGSN, to this, and then to BSCs, and then to your mobile phone, right? So at that time, the relatively GPRS has a good speed relatively at that time, right? Not when comparing to these days, right? But later on, some advanced techniques like Edge came to the market, so it has some more data rate when compared to the GPRS. So GPRS, if I can remember, it is around 30-40 kbps, but it was around 300 odd kbps in Edge, right? So kind of huge improvement at that time, right? So this is the 2G communication, right? Yeah, I have put some information in the slides as well. So it is packet switching. You have two different components, the GPRS, right? So this is the gradual improvement of the GSM networks. Okay, now then we are coming to the third generation. So as I discussed, there should be a significant improvement from 1G to 2G and 2G to 3G. And so I have list some of those things. So there were different standards like UMTS, Universal Mobile Telecommunication Systems, right? So it is a kind of CDMA, right? WCDMA. So now the 3G has improve the data speeds, right? So now you have some proper data communication or mobile internet access. So video calling features, online gaming, right? So a lot of features are there. Then the speed was around 2 Mbps, right? And some other techniques like HSPA, HSPA plus, right? So likewise, different techniques were there. And now in here, so when we are discussing the security issues as well, so we'll discuss this. And now the security issues come to a different level. The reason is now the manufacturers have introduced a different kind of mobile phones. So now they have introduced smartphones, right? So when it is 2G, if you can remember, they had some devices, not the smartphones. And so you had some, we call them as feature phones, I think, right? So there are some options, right? So yes, you have some color displays, but the keypad was there, right? So, but now when it comes to 3G, you have some different level of devices like smartphones. So example is the first iPhone. It is introduced in 2007. If I can remember, they named this at 3G as well, right? So because the mobile phone had the 3G capability. So now they were able to do a lot of things using internet, right? And there were applications. So from this point onwards, the security was or the vulnerabilities and attacks were shifted to a different level because now you have softwares in the device, so which means there are vulnerabilities related to softwares and OS as well, right? So the problems comes to a different level at this moment, and then you have a better data rate, so attackers can attack the devices in a different level. right? So blended with the circuit switch, that is again for the voice. So you are using circuit switching network for the voice, but packet switching networks for data, right? So have some security measures, the AKA like kind of protocols. So we'll discuss them separately. So some improvements, right? Not some, but huge improvements when compared to 1G and 2G, right? So one important thing that you have to remember here is the smartphones. So the introduction of the smartphones. So this change a lot of things in the mobile phones, because up until now most of the mobile phones were used for voice communication, right? So they were voice centric, right? But after this point onwards, it's more towards data, right? So it become data centric, not for the calls, but for other things as well, right? So this is kind of a huge change for the mobile networks. Yes, I have put some diagram about the architecture. So you can see that some names have changed. Now you don't have the base stations, you have nodes. So you name them as nodes. So base stations were named as nodes, right? So likewise you have RNC, so that is the controllers, right? And again it is connected to MSCs, and this VLR, HLR is there, right? SGSN is there, GGSN is there. So all the things are there, right? But some changes, right? So again, you can see that it is connected to PSTN and the internet. So the same architecture, same infrastructure, it is going to upgrade, right? So changes are there, right? Okay, now it is beyond 3G, that is LTE, long-term evolution. Basically, this is the 4G, right? So 4G that is introduced in late 2000s, right, to around 2009-10 period, right? LTE was introduced, right? Now this is a huge change, because now they introduce this voice over LTE features, where now it becomes more IP network architecture, right? So this is some changes, and I have put some technical things as well. So if you like, you can read them. This orthogonal frequency division multiplexing. So the multiplexing has changed, right? So that is the difference between 3G and LTE. So likewise, I have put some pointers. So if you like, you can search them and read, right? So the speed has improved, right? So there's a huge improvement in speed when we come to from 3G to 4G, right? And the devices get improved. So a lot of changes when it comes to LTE or 4G. And I have put the architecture as well. So there's a link. You can go to the link and read more about this, right? So again, you have this user equipment or the device. So it should have the SIM or whatever uh, uh, the information to communicate with the cell tower. And you can see that again the names are changed. So initially in 3G you had node B. Now it has become E node B or ENB. In some situations you might see it as ENB. So what it says is evolved node B, right? So not the normal node B, it is now evolved or improved, right? Evolved node B, that's why NB, right? So the same thing, but some improvements. So you have some new components like MME, right? That is mobility management entity, right? Some new components. So these things are the components which manage these different sessions, authentications, kind of things, right? And you have this HSS, that is home subscriber server, right? So that is one part of this LTE network, right? So it is a user database kind of thing, and so the infrastructure has little changes, right? Okay, so yes, I have put some information about the UE, ENB, HSS, right? So details about the customers and all the things. So 4G, right? All IP network architecture, high-speed mobile broadband. Yes, voice over LTE, right? Voice become IP data service, right? So now the network is pure packet switching network. So now we have changed it a lot. So the speed has improved, right, from 100 M to 1 gigabits per second, right? So huge improvement in speed, and the devices also get improved, right? Not like in the 3G or 2G. So devices have improved. Okay, right. So the major difference between 3G and 4G cellular network is 3G operate entirely on IP protocol and architecture, right? So that is the major difference between 3G and 4G. Clear? Okay, now then we have to discuss the security issues and the methods that they have used to reduce these security problems. So let's keep that for the next week, right? So we have discussed a lot of things today, starting from the mobile network. So I will just summarize the things and end the today's session, and we will discuss the security stuff in the next week, right? So we start our discussion from PSTN, that is the public switch telephone networks, because we need to have some idea about the networks, the basic or the wired telephone communications before going to the cellular networks, right? So we discuss how these things happen, and the people want to do the data communication, but they don't want to change the infrastructure, so they convert the digital signals to analog and use the same infrastructure and do the communication. So then they have found out that at the same time they can't do both the things, voice and data. They want a solution and they want to improve the speed. Then they introduce the DSL, right? So it divide the bandwidth into different channels and allocate specific purposes for each and every channel. Then we discussed packet switching and circuit switching. Then we came to the cellular networks and why we call them as cellular networks. Then we discuss this different cellular architectures. So please read about these things. So just find the difference between each and every technologies, right? And in the next week, we'll discuss the security issues and how these things were solved in each and every uh, technology or in each and every generation. So we are not going to discuss in technical details about these things, about the protocols and all the things, but we'll discuss some basic ideas how they are going to protect the network, right? Uh, so yes, that's all about it. So that's enough for the day, right? So we'll meet on next time, and that will be, I think, the last session uh, for this course, right? Okay, then. So that's all for the day. So if you have any suggestions or any things to add up, you can share it with the others. If not, we can end the today's session.
Okay, sir. Thank you.
Right, okay, I will share the lecture note. Thanks.
Thank you, sir. Thank you.
Thank you, sir.